Hello everybody. Today we are going to be talking about how to name ionic compounds. So in the last video we talked about how to make ionic compounds, but now we're going to talk about naming them. So there's very simple rules for naming binary ionic compounds. Remember, these are metals and non-metals, and simply we need to name the metal. That name does not change. If the metal has multiple valences, then we have to include a Roman numeral to show the charge. You can see your table of common ions, which I believe will be posted on your classroom to see which ions will have to use the multiple valence rule. But some good examples are copper and lead, and I believe it's tin. I think tin is the other one that we use a lot. And so we'll see a couple examples in a second as we go through. Now, when we also have to name the nonmetal, and to name the nonmetal, we simply name the element and then change the last few letters to the word "ide," to the sub prefix, postfix, a postfix named "ide." All right, so here we have aluminum and fluorine. So that means that we're going to write aluminum out normal. We would check our table of common ions to make sure it's not one that has multiple valences. And then we'll name fluorine, but then I want to try to replace sort of from the last vowel to the end, I want to replace that with "ide." So in this case, my last vowel is that I. So I'm going to go fluoride. And in the most part, just, whatever sounds right. But, try to do your best. That's essentially the rule, is from the last last vowel, you're going to replace it. Okay, so you have Na and O. Na is for sodium. Sodium is an early periodic table element, so it's on the left. It only has one valence. All the ones with multiple valences are in the middle or in the last sort of area of the periodic table, the bottom area. And then we have oxygen, but in this case, we actually, I guess we go a little bit farther than I was expecting. We kind of go to the letter that sounds the most like Y, like an I guess, which would be to go all the way to the Y and go oxide. So it's not really a great clear-cut rule, and that's what I'm struggling with to give you some advice here. The best route is possibly to just memorize everything. So here we have a K, that's for potassium. And the chlorine, and again, we see the letter I, so we're going to go to that letter I, and then we're going to finish up by changing it to ide. So chloride. Here we have barium, and then we have bromide. It would be normally bromine, but we are going to replace the I and E with bromide to indicate that it's an ion. If you wrote if you wrote something like barium bromine, what I would be imagining is something that looked like this, barium bromine, and it would be separated. They wouldn't be together. So to indicate to the reader that they are together, we need to include that IDE. That's how you tell that they're a pair. So here we have zinc. So we have a zinc, and we have chloride. Now, zinc is one of those examples where it can have multiple charges. So in order to represent that, or to figure that out, we have to go back and figure out how much charge do we have. So chlorine was -1, and there are 2 of them. So I had a total of 2 minus. So what was the zinc? The zinc must have been +2 in order to balance out that 2 minus. So this is zinc 2, and that's the Roman numeral for 2. Finally, we have beryllium. This is a fun one to spell. Beryllium. I think there might be 2 L's. And then it's iodine, but I'm going to make it iodide to indicate that it is a ion. Now, in this case, we do also want to consider that we should probably be using lowercase letters for the whole thing, or a single uppercase letter for that first letter, because that would be its name. Magnesium. And oxygen again turns into oxide. Aluminum. And then it's sulfur. And I'm going to go to that. I'm going to use that rule about that sort of soft rule about the last, the nearly last or last vowel. Thank you. My brain is not working today. Apparently, sulfide, like so. Here's another one with magnesium. This will be again magnesium sulfide. Now you might sometimes see it spelled out this way. This is fine. That's actually technically, I think, the American or the Canadian spelling would also be that way. So, you know, if you want to be more Canadian in your writing, then that's totally acceptable. And if that's what you feel like. I'm trying to get this to work here. Okay. And the next one we have is a calcium, and this would be fluoride. And now we have a lead, and this is another example of a multivalent element. So I'm going to write out the lead, and I'm going to write out the oxide, but I need to figure out how much charge was on that lead. So I go to my ion table, I find out that oxygen has a -2, and there's only one of them, so I need to balance that with an equal charge. So I'm going to use +2. So I need to use lead 2. And this is because there are some occasions, especially if you make this lead at, say, if you heat the lead up or do some chemistry to it, it can turn into lead oxide like this. This one is also called lead oxide, and if we did not use this labeling system, it would be impossible to tell the difference. But the extra oxygen means that although they both have a -2, we have a total of -4 down here. 2 times 2, -4. So that means the single lead must be providing a +4 charge. And that means that this is +4. So the lead is not 2, but 4. That would be lead 4 oxide. So just a quick reminder on your icons. This is 1. We have 2 lines for 2, 3 lines for 3, a line and a V for 4, so 1 before 5, a V for 5, and maybe the last ones we might see is a 6, which is a line after, 1 more than 5, and then 2 more than 5 would be 7, and 3 more than 5 would be 8, 1 less than 10, IX, is for 9, and and an X is for 10. Okay, so those are your Roman numerals in case you need a reminder. Okay, so let's look at this iron. This is probably the hardest one, is when you get these iron compounds, and of course you could just memorize them. It's still an oxygen, so it's got to be that oxide. It's also got to be just the basic name, iron, but we need to know which iron it is because there's lots of different irons. So again, we have a -2 on oxygen. That means that in total we have -6, 2 times 3. So what is the iron? The iron must be +6. And so in order to figure out this +6, we've got to go through this 2. So we're essentially dividing 6 divided by 2, and that gives you +3. So we would be expecting 1, 2, 3 in here with that iron. All right, and that's it. You now know how to name ionic compounds. There's a lot of ionic compounds to practice with. And we're going to provide you with some examples to work through and an assignment, and that'll be that. All right, good luck, and we'll talk to you soon.